Very pleasant good afternoon. In this video, I'm going to discuss about clustering concept. What is cluster analysis? How to find the clustering of grouping of item? What basis we are going to group the item? How to determine the metrics measure of the clustering concept? And what is the real application? What about the requirement of cluster analysis? These are all the concepts I am going to learn from this video, right? So, what is cluster analysis? What is cluster? Then we can go for cluster analysis. So first thing that is collection of data items. Take this example, the grapes is called as one of the similar clustering. The collection of data object that is called as a cluster. What is the special characteristics of the collection of data object? Well, are similar or different. So all those objects similar to one another that should becomes under the same cluster or single cluster. So dissimilar object. So dissimilar objects that are should be in different clusters. So take this example. Those who qualified with the maths along with physics, chemistry, and then either computer science or biology. That students are eligible for doing computer science. So these kind of students are categorized into one group. That is the students are eligible for doing BSc computer science. So even the other students maybe the students may be a third group. Maybe take as example for accountancy, commerce, economics. That students are eligible for taking either the history or economics. So accordingly, we can categorize the students in different major. So that is the main important. Similar the object one another based upon some special characters within that should become under single clusters. And the decimal object that should be in other classes. So it is completely different. Taken this will be applicable for any kind of product, maybe cylinders and pulses, or maybe animals, or maybe fruits and vegetables, or any kind of human we are applying. So those are educated, uneducated, based upon the business analysis. We can categorize the people in different sectors. So that is the main thing for clusters. But cluster analysis, finding similarity between the data according to the characteristics found in the data and grouping similar data objects into clusters. Similarity in this is that's according to the characteristics found in the data. What characteristics? If they teaching in the sense they may be qualified with PhD or maybe related selected. That is a teaching character of fraternity. Or maybe taking as example for the business people, they have some domain knowledge in particular area. So business people may be different kinds of business. Accordingly, the group of people under the one sector that should be considered special. That is characteristics. So based on that, we are going to find the similarity. So actually, this cluster we have considered set of group of people that is considered set of tuples. Each tuples have a set of attributes. Yes, we consider different kinds of attributes, but we does not have the class label for those attributes. Hence, it is called as an unsupervised learning. So no predefined classes. That's most important. What is the difference between the supervised learning and supervised learning? Supervised learning in the sense all the tuples should be contained in the class label. Unsupervised learning, the tuples does not contain any predefined classes, right? So here we are going to apply typical example, standalone tools to get the right data, or some pre-processing steps for other algorithms. So these are some of the applications, but we come to real life applications. So that is how to apply the that is clustering, how to apply the clustering for multidisciplinary pattern recognition. So how to determine the pattern. Spatial data analysis. Spatial data analysis, we can determine the that is create the maps and GS by clustering the features of space and detecting the spatial cluster or for any other spatial mining task. So we are going to go for spatial data analysis. Image processing. So how to process the image we are going to that cluster all the pictures accordingly we determine the images. Economic science, spatial market research, how to determine the customers whether he is a or economic science in the sense market basket analysis determine whether the customer is a big spender or maybe budget spender. Accordingly, we can determine the science. So also we can use the document classification and cluster the web data, web log data to discover the group of customer buying patterns. So because of when you if you have a website for college websites, so most of the anyone can access the website. Maybe student or maybe any other people try to find the number of courses in this institution, or maybe students they may be registered for cyber security, or maybe they can do for some other economic exam purpose they may be do that. So how many of them how many of candidate they view the website, and then how long they are searching, what kind of data, what kind of information they are gathering from the website. That kind of information have returned into the web log file when he or she enter into the website. So based on that, we can go and analyze the data from the web log files and analyze the data. We can find that how many the customers, different kinds of customers, what they are searching, what kind of operations they are expecting. So that kind of information we can use it to identify by using the clustering concept, right? And next we can go for that examples of clustering applications either we can use for marketing, land use, insurance, city policy, earthquake studies. So these are all the examples for clustering applications. For clustering applications, the first thing that is marketing in the sense help the marketers discover the distinct group in the customer bases. They can use their knowledge to develop the targeted marketing programs. According to the customer's group, we can determine the develop the targeted marketing programs. First thing. And land use. Identify the area, the similar land use in the Earth observation database. Earth observation database, we can determine similar land use, right? So that is a clustering because of either it is a block soil or maybe a red soil. So what kind of agriculture is used for this particular plant? That kind of information can be found by the clustering application. Even for agriculture, the people they are doing cultivating some of the soils and pulses based upon the soils of the uh, characters, features. So insurance, identifying the group of motor insurance policy holder with a high average claim cost. Maybe a claim cost based on the claim cost. Maybe the policy insurance policy maybe policy holder maybe insurance for insured maybe 10 lakhs or 15 lakhs or maybe 2 lakhs or 3 lakhs. Based on that, we can go for with a group of motor insurance policies. City planning group of houses according to the house type and values and geographical location. Based on that, we can determine the house values, right? And earthquake studies observe the earthquake epicenters and clusters along the continent forest. So these are the several applications we can apply the clustering concepts. So how do you determine whether the clustering is a good or not? How to determine the clustering qualities? A good cluster method produce the high quality cluster with oneness, high intra-class similarity. That's most important. Intra-class in the sense all the object should be in a single cluster. High intra-class similarity, low intra-class similarity. That is two different classes. No, intra in the sense within the institution, inter in the sense two different institutions, assume like that. So two inter-class similarity, low inter-class similarity, high intra-class similarity. That is the way we can determine the quality of the clusters. The quality of the cluster result is depends both uh, uh, similarity measures by use by the methods that is implemented. Actually, the quality of the clusters are determined in terms of similarity. Similarity scores lies between 0 to 1. If it is 1 in the sense, the both objects should be more related. It should become under one cluster. 0 in the sense, so it is not similar, dissimilar object. That should be put in a separate two different clusters. That's it, right? And then we can determine the measure of the quality of the clusters, the dissimilarity or similarity metrics that is used to measure the quality of the clusters. Similarity is expressed in terms of distance functions, that is matrix d of I comma j. So this is a separate quality function that measure the goodness of the clusters. So, and then the definitions, the distance functions are usually very different for interval scale, Boolean, categorical, ordinal ratio, and vector variables. So these are all the different types of variables used in the clusters, but the distance functions is differ all depends upon the data types we use, and may be associated with the different values based upon the application and data semantics. Okay, and it is hard to define the similar enough or good enough. The answer is highly subjective, right? So this is different measures and different data type which is used in the clusters. So next we can consider that different requirement for the clustering data miners. What are different requirements? Scalability, the ability to deal with the different types of attributes, the ability to handle the dynamic data, discover the clusters of arbitrary shape, minimum requirement for domain knowledge to determine the input parameters, able to deal with the noise and outlier, insensitive to order of the input data, high dimensionality, incorporate user-specific constraints, interoperability and usability. These are all the requirement for successful defining the clustering data set, clustering of the data. Scalability in the sense we know that all scalability algorithms should be work for some small sample data set, some small data set. Suppose if you are going to increase the maybe 1,000 or maybe 2,000 record huge volume of data, in that scenario that algorithm is not sufficient to support for that data. The scalability is not supported. That is one of the issues. How we are going to overcome that issues for the clustering of the concept. Second, ability to deal with different types of data. Most probably, we are have considered only the numerical data. If the data may be ordinal or may be vector or may be interval scale variable, so in that type of data, how to handle an efficient way to find the clustering concept. That is the next important requirements for research analysis for the clustering data. And third one, ability to handle dynamic data. Suppose we already the data should be prepared and then applying the cluster clustering concept, then we can categorize, then we can find the grouping of the data. But suppose some data may be dynamically at runtime presented. How to handle the data in efficient way to cluster into particular group. That is most important because of we have to plan all the training data, static data, and then by using those data we are going to handle the finding the clusterings. So if some new data is coming during the runtime, how to handle that kind of problem we need to solve it, and then discover the clusters with the orbital shape. Normally, spherical shape of the clusters is easy to discuss, but any different orbital shape, how to handle the classification algorithm to find the orbital shape, and in order to classify the group the data after this classific group clusterings. And minimum requirement for the domain, that is domain knowledge to determine the input output parameter. Yes, so that before to enter the clustering concept, what is the we need some minimum requirement for domain knowledge is most important. Without the domain knowledge, we are not understand what kind of thing we need to do for that algorithm. So that minimum requirement is required for minimum requirement is needed for the domain knowledge for efficient executions of the clustering in data mining, and then able to deal the noisy and outlier data. Some of time you have the data tuples. That tuples may be consist of some noisy data or some outlier inconsistency data. In that scenario, that's a classification algorithm try to find that reduce that issues the noises outlier, and then based on after that we're going to properly cluster the data into some similar groups. That kind of requirement is needed for the clusterings. And insensitive to order of input parameters. We are all know about that. We are going to call the function. We need to pass number of argument, order of argument, type of argument. That is most important in any languages. But what they here expected, in any order we are passing the input record, it is automatically the algorithm accept the input and process that and then determine the similarity measures. That is most important for the next requirement. High dimensionality. We learned it either two dimension, that's it, single dimension, two dimension. Suppose high dimensionality in the sense different kinds of attributes are included for the data set. In that scenario, how the clustering algorithm is working fine to find the exact class of that is similarities. That is determined. That is the most important text requirement of the clusterings. And incorporate user specific constraint is of course And still now we learn about the scalability, how to deal with different types of attribute, how to handle the dynamic data, what about the, that is, we need some domain knowledge, and noisy, how to handle the noisy data. But here, representing is a user specified constraints. Suppose if you're going to build or finding the location to incorporate the ATM machines, that we need some of the constraints to satisfy most mobile, that is public that is most important locations, maybe near railway station or maybe bus station or maybe terminals or any that is most of the people's moving in and around that locations is needed to find. Similarly, we are going to find that incorporating user specific concerns the most important, that should be included uh, for defining the clustering similarities. So for clustering the concept and interpretability and usability in the sense, when you are going to use the clustering algorithm, it should be an interoperable. That is most important, and then it will become to the usability of the real uses. So based on these are all the most important requirements of the clustering. Then we are going to refer all those concept in a clear way. Then we can use that clustering concept is the most important way of applying to the real life scenario. Thank you for this clustering concept content.